Physics 2B Part 2. Right, name 3 wires in the 3-core cable. You've got the live, which is brown, the earth, which is green and yellow, and the neutral, which is blue. The earth wire is green and yellow for protecting wire and for safety. The fuse, this works with the earth wire. There's the fuse. This works with the earth wire here and prevents fire and shocks. Now this fuse is attached to the metal casing. There, the metal casing of the plug, and carries electricity and earth away from you should something go wrong and live or neutral wires touch the metal casing. But this has to break before it stops the electricity. That is, the wire inside there has to break. Now, what you need to know is what RCCB means, and that's the residual circuit breaker. Here's a circuit. What you do is, beforehand, you add that to your circuit. Right. They operate faster than fuses, no waiting for the current to melt. They work with even small changes in the current. So if there's a change in the current there, with that attached, then what happens is that it snaps the circuit, stops the electricity, and the result of that is that you don't get hurt. Which uses more energy? 45-watt pair of hair straighteners used for 5 minutes, or a 105-watt dryer used for 2 minutes. There's the formula. Q equals I times T. Alright. 45 times 5 minutes times 60 equals 13,500. Now the other one is 105 times 2 times 60, which equals 12,600. So obviously this one is the larger, so the hair straighteners use more electricity, more energy, even though they're used for 5 minutes. And the hair dryer, though, no, it's not even though, they're used for 5 minutes, that's used for 2 minutes. You'd expect that this one with a larger wattage would take more, but it doesn't. You've got 3 fuses which you put into this. If you put the wrong fuse into things, then you'll damage yourself. A toaster rated at 230 volts, 1100 watts. An electric heater rated at 230 volts with 2000 watts. So you've got 3. You've got a 13 amp fuse, a 5 amp fuse, and a 3 amp fuse. What you've got to do in the exam is to say which is which goes with which. Here are the answers. So 1100 divided by 230 equals 4.8. So the result of that is that you can use a 5 amp fuse for the toaster. Now if you take this and say 2000 divided by 230 equals 8.7. Now that means that you can use a 13 amp fuse. Since you've only got 3 or 5 or 13. If you use a 3 on this, it would take too long and you'd get damaged. If you use a 5 on this, it wouldn't last. Right? And 13 is the one that would work with it. E equals Q times V, so 530 times 6 equals 3180. Alright, so there's the answer. Calculate the energy transformed is that. Ernest Rutherford and Marsden led nuclear model of the atom. Explain how they led. Ernest Rutherford's grandson lives in Beminster in Dorset now. You can probably pass his way onto school if you're in Beminster. Right, Rutherford and Marsden tried firing a beam of alpha particles at a thin gold foil. They expected positively charged alpha particle to be slightly defective, but most of it went straight through, with the odd one coming back. Now that meant that the atom had a concentrated centre of tiny nucleus, meaning that the atom was mostly open space. Alright, there's the table stating the relative mass and charge of 3 basic subatomic particles. So you've got proton, the mass is 1 and the charge is +1. Neutron 1, 0. The electron 1/2000, -1. I'm afraid you've just got to learn these things. True or false? Radioactive decay can be triggered by certain chemical reactions. False. What type of subatomic particle is a beta particle? Beta particles move quite fast and are quite small. Electrons with no charge and a charge of -1. Alright, so there it is. Move quite fast, are quite small. List 2 places where level of background radiation is increased and explain why. First of all, look at this. A weak source of alpha radiation is detected near 2 electrodes. The source causes ionization and the current between the electrodes, if a fire smoke, will absorb if a fire smokes, it'll absorb radiation, so the current stops and the alarm sounds. Now look at this. High doses of gamma ray kill all living cells, so can be used to treat cancers in hospital. Now they need to be directed carefully and just the right dosage to kill the cancer cells, and not too many normal cells. But some get damaged as well as cancer cells being killed, and not the patient. Alright, so name 3 occupations that have increased risk of exposure to radiation. teacher, zebra crossing bloke, shopkeeper? No. A radiologist, a miner and a jet pilot. Sketch the path of an alpha particle and a beta particle travelling through an electric field. Particle move in opposite directions in a magnetic or electric field. Alright, so there's the beta particle going that way, there's the alpha particle going that way. What is defined as a half-life? The average time it takes for the number of nuclei in a radioactive isotope sample to halve. You must learn this definition. Half-life is the average time it takes for the number of nuclei in our radioactive isotope sample to halve. Halve. Alpha radiation is the most dangerous form of radiation if the source is outside or inside the body. If radioactive source is inside the body, perhaps after being swallowed or breathed in, alpha radiation is most dangerous because it's easily absorbed by cells. If radioactive source is outside the body, alpha radiation is not dangerous because it's unlikely to reach the living cells inside the body. Which is the most dangerous form of radiation if you eat it? Alpha radiation. Describe precautions you should take handling radioactive sources in a laboratory. Look at this, and look at this. This is a lead screen. This is radiation. If you're conducting experiments, keep exposure time to a minimum. Never allow your skin to touch radioactive stuff. Use tongs. Hold radioactive stuff at arm's length, far from the body as possible, especially near alpha cells, which don't travel far in the air. Point to radioactive source away from you. Avoid looking directly at it. Always store radioactive sources in lead boxes. Put away from you as soon as possible. Stand behind lead screens. In X-rays, only the bit needing treatment should be exposed to radiation. The rest should be behind lead. Draw a diagram to illustrate fission of uranium-235 and explain how chain reaction works. Here's a chain reaction. Each time uranium nucleus splits up, it spits out two or three neutrons, of which one might hit another nucleus, causing it to split, and so on. So that splits and becomes that. One of those hits something else and becomes that, and so it goes on and on, splitting and hitting. That's a chain reaction. What is the main environmental problem associated with nuclear power? If you look at the picture, it's the result of Chernobyl, a nuclear power station that erupted. What's the main environmental problem associated with nuclear power? Disposal of waste or a nuclear accident. Alright? That is the result of a nuclear accident. That's only one of the problems. Look up Chernobyl. What is nuclear fusion? Why is it difficult to construct a working fusion reactor? Two light nuclei, hydrogen, can join a larger nucleus and this is called nuclear fusion. Now, the big problem is that fusion can only happen at really high temperatures. 10 million centigrade. Now if you consider the temperature outside today, this is in March, is about 8 degrees centigrade, then you can see that nuclear fusion is quite difficult to achieve. But at the end of it, there is no waste. So you couldn't get another Chernobyl happening. Alright, stars form from clouds of dust and gas because of gravitational forces. These are converted into heat and energy, so the temperature rises. When that's high enough, the hydrogen nuclei undergo nuclear fusion to form helium nuclei and give out massive heat and light. That's a star. Why will our sun never form a black hole? Well, basically because it's not big enough. Stars about the same size as our sun eventually become unstable and they inject their outer layer of dust and gas, leaving behind a white dense solid core known as a white dwarf, which becomes a black dwarf and disappears. Right, this is physics part 2, and that's the end of the physics section.